Welcome to Basic Power System Analysis using PSSE. Now that we have prepared the entire model in PSSE, the next thing we need to do is enter the data into it. So we are going to start from buses. So if we go here and see, the first bus has a number 1, name is bus A, and it's a 132 kV bus, and since it has a generator connected to it, it means it is a generator bus. So we'll go to PSSE, just double click on the bus, we will give the name 1, we will give the bus name, then we are going to give the base kV, and from this type code you can select different buses. So for the generator bus we have bus 2, we'll select bus 2 for it and press OK. Now if you see, the line which was dotted before has become solid. This means that now the software understands that the generator is now connected to the generator bus. So for the transmission line, before going to transmission line, let us enter for another bus. So same way, we are going to double click on this. This opens. We are going to check what is the data for this bus. So it's bus 101, bus B, 132 kV. So here we go. Bus number is 101. This is bus B, and this is also 132 kV. And since this is a load bus, so we are not going to change the type code for this bus. We will press OK, and we are done with this. Next, we are going to enter the data for the transmission line. So transmission line, we are going to double click on the transmission line, and there the data is open. As I said, this data will be automatically filled up by PSSE. What we are interested in to enter is the branch data, the line R, line X, and line B, which we have already calculated in per unit. Also, we are going to give this rate A. Rate A is going to tell us what is the 100% capacity or the thermal capacity of the transmission line. Similarly, this length is just for the reference purpose. It has no other reason. So even if we do not enter the length, we will have no difference in the calculation. But by entering this length, this gives the PSSE user or another person who is viewing this case the reference that what is the length of this transmission line. So let's go on and start. From the case, we see that this is a 550 kilometer Linux conductor. So if I go to my Excel file, I see here 50 kilometer Linux conductor has these parameters. So I'm just gonna copy here and paste here. Similarly, for X, I'm gonna copy this value of X and paste the value of X. Similarly, value of B, copy from here and paste it here. If I see here, the Linux conductor has a capacity of 112 MVA. So I'm gonna go here and put 112 MVA here, and the length of the circuit is 50 kilometer. So I'm gonna 50 kilometer here and press OK. Now PSSE is giving me a warning that I have turned my zero impedance line. Yes, before the value of the X was 0. So it is saying the value, this branch will no longer be a zero impedance line. That is exactly what we want. We want to put some parameters into the line. So I am okay with this. I'll press OK, and that's it. If you see, the data has been updated into PSSE for this line. It tells about the circuit 1 from bus A to 101, and this value has been updated. So I'm going to go quickly and add the data for the second line also. Now in the same way, let's add the data for this third bus. Since this bus is also a generator bus, so if we double click Let us see what is the data we need to enter. So this bus is number is 201, name is bus C, and it is 132 kV bus. So let us go here. So we have 201, we have bus C, 132 kV bus, and since it is a generator bus, so from type code we are going to select, press OK. So we are done with this as well. So now let us enter for the next bus, which is an 11 kV bus and 301 bus D. So this is 301, this is bus D, this is 11 kV, and since this is load bus, no need to change this value. Press OK. So now let's enter the data for the generator first. For the generator, if you double click same way, double click on the generator, and this data window is going to open. For load flow analysis, as we discussed before, two things are important: the active power, which will be the dispatch of the generator, and the reactive power capability of the generator. Because for the PV bus, PSSE needs to know these two things. Even if we do not enter other things, it is not going to impact our calculations. For short circuit analysis, the additional data we will be requiring is the base MVA and the reactance of the generator. But since we are not working with short circuit analysis, therefore no need to enter these values. So the three important values here are Pgen, Qmax, and Qmin. If I go here and see, Pgen is 100 megawatt, Qmax is 60, Qmin is minus 20. So I'll go ahead here, put Pgen as 100, no need to change this, no need to change this. Qgen will be calculated automatically by the software. Value is 60 and minus 20. I'm going to press OK, and here the data has been updated in the generator. In the same way, I'll just double click on this generator and put the same data. For the transformer data, let's double click on the transformer here. The important data for load flow analysis is the transformer reactance and this rating of the transformer. Rating is important because when we will take the results, we want to know that our transformer is loaded how much as compared to this rating. Similarly, we have already converted our reactances into 100 MVA. So winding MVA, we are already considering 100 MVA instead of 20 MVA for this transformer. So let us go ahead and put the value here from the Excel. Let us first check from here. So 132 by 11 kV transformer has a reactance of 10% at 20. So if we go here, 132 by 11, the new is 0.5. So I'm just gonna copy this value and paste it here. For this rating, you see the transformer has given two ratings, the 20 MVA and 26 MVA. What does this mean? These ratings are basically based on different configuration or a different combination of transformer. The first one is usually known as on-an, oil natural, air natural, and the other one is known as on-F. When you put the fan on the transformer, you try to reduce the temperature of the transformer in order to increase its capability. So here we are going to use the maximum capability of the transformer, that is 26 MVA, assuming that once the transformer load exceeds 20%, the on-F capability, the fans are going to be turned on automatically. So we go here and put 26. Just for a reference, for B, let's put this, and we press nothing, no other data needed for load flow analysis. Just click OK, and we are done with this. At last, let's enter data for one of the load. So I'll just double click on this load. As per this diagram, as the load is 150 megawatt, we have already calculated the Q for this value. So let's go ahead here. So 150 and this is 72. So just let's copy this Q, come back here. P megawatt load is 150. Q value we have already copied. Copy it here. Okay. Now you all can go ahead and put the remaining data for this part of the system, and we'll be back to perform the load flow analysis. That is all from this video. Thank you.